So a cube, see figure 1, is made up of 27 smaller cubes, small identical cubes, each having a side length of x. A sphere of radius x is cut into 8 identical square hemispheres. The 8 corners of the cube are removed and replaced with 8 pieces to form a paperweight as shown in figure 3. If the total surface area of the paperweight is 28 cubic millimeters, determine the size of x. So the surface area for C is 4 pi r squared. So just from this diagram, the final diagram, we can say that the total surface area here, the easy part will be the open faces that we see. If we can see that this cube has 6 sides, so 1, 2, 3, 4, 5, and the one at the bottom 6, and each has 5 open squares on it. 5 times 6, that would be 30. So the first part of the easy part would be computing the area of all those small little um, squares, and there are 30 of them, each of a length of x and x on each side, so it's 30x squared. Then we get to the complicated part. First of all, we have these exposed areas, and then we have this part that is semi-exposed, but a part of it has been cut out because of the square, because of the sphere or part of the sphere. Anyways, what we need to do is we need now to get the area of this exposed bit, and we can see that there's 3 of them. All 3 of them are identical, so we need the area of these parts, and we can see there will be how many of them? 1, 2, 3. So there will be one in this corner, other in this corner, the other one in that corner, the other one in that corner. 4 on top and 4 at the bottom. So yeah, that's going to be that. And then we also have the area of this exposed quarter piece, or not quarter, but an eighth of a circle over here. And we need to compute 4 of them as well. So let's start with those, since those are much easier. This is basically just an eighth of our circles. So we can say this plus, in brackets, 1 over 8 times the surface area of a sphere is 4 pi r squared, but r in this case we are told that the radius is x, so that's just going to be 4 pi x squared. That's the first part. Now we need to get the second part that I was talking about, the one with the 3 faces over here. So overall, we're going to multiply this by 8 because this is just for one face. But since there's 8 of these ones as well, we might as well compute them once. So this is going to be plus 3 times, because at each corner, of which there are 8 corners, there are 3 of these smaller triangular looking faces. But basically, if you were to draw the side view, it would basically just look like this, where this part is just taken out by a quarter of what would have been a circle, right? So this is what the full circle would have looked like, and we are only looking at this part that is being taken away. So this is the exposed part that is left. We need to compute the area of this part. So how do we do that? We basically take the area of the entire square. Oopsie. So area of the entire square, and then subtract the area of the quarter square that is there. So the quarter of a square, we know that the area of this is pi r squared. So this smaller part here is going to be 1 over 4 pi r squared. Yeah, and r in this case is x. So basically we're going to say x squared, which is the area of this entire thing, x squared minus 1 over 4 pi r squared is going to give us the area of the blue part. So, and there are 3 of these instances, because there's one here, there's one here, and there's one here, and this is all happening at this one corner. So at one corner we have the area of the exposed eighth of a circle, and we also have these little bitty parts. So we're gonna say plus 3 multiplied by x squared minus a quarter pi r, which is x squared, Um, and then we said how many of these corners are there? 4 on top and 4 at the bottom. That's a total of 8. And we're saying this has to be equal to 28 millimeters square for the area. But for now, just write 28. Then comes the algebra. So from here, we need to multiply certain things, and that's gonna be, we're gonna have, let's see, 1 over 8. We can start with this 30x squared, and then over here, that's just gonna be a half. So that's a half pi x squared plus 3x squared minus 3 over 4 pi x squared. So if you combine all of these, you're going to get 24 plus 24 x x squared minus 2 pi x squared, and this will give us 28. Then remember, all we're solving for is our x. So we have 30x squared minus 2 pi x squared and 24x squared, and we're gonna factor out x squared from each. So x squared, that's just gonna leave us with 54, or 30 plus 24 give us 54 minus 2 pi. This is equals to 28. Divide both sides by 54 minus 2 pi, and we have that x squared is equal to um 0.766, and with the total surface area, determine the size of x. So you can just round this off to whatever decimal places they've asked you to. So yeah, let me just write the in steps over here. This will be 28 over 54 minus 2 pi. The square is still there. Take the square root of both sides, then you get 0.766, or roughly about 0.77. I mean, yeah, you can write it as 0.77, or you can write it as 0.8 millimeters. So as long as you remember your units, you should be fine.